In this next example, with the distance formula, we get to see how using the Cartesian plane allows us to translate geometry problems into algebra and vice versa. So consider the 3 points A, B, and C with their coordinates. And so we are going to first plot each point to form the triangle. Then we will find the length of each side of the triangle. Then we will verify that the triangle is a right triangle and find the area of the triangle. So first, we will plot the points. So A is -2, 1, so -2 up 1, and that is point A. And then B is 2, 3. And then C is 3, 1. And that is C. And so this will form a triangle. And there's our triangle ABC. So we can find the length of each side of the triangle by using the distance formula. So we will set up 3 different equations here. And so we have the distance between AB and that is, so I'm going to find the distance between A and B. So using my distance formula, I've got, so B, here's my x value, so I've got x2 minus x1, so 2 minus -2 squared plus the difference in my y values, so 3 minus 1 squared, and I can simplify that. And so I get 2 minus 2, 2 minus a -2, which is going to be 2 plus 2, which is 4 squared. So that's 16. Plus 3 minus 1, which is 2 squared, which is 4. And I get the square root of 20. And I can simplify that. If you recall properties of radicals, we can write this as the square root of 4 times 5. And 4 is a perfect square, so I can rewrite that as 2 radical 5. And of course, I could turn this into a decimal if I wanted to, but I'm perfectly fine to leave it as a radical, okay, which we will do sometimes just depending on context. So I've found this piece right here, AB, so that's 2 radical 5. Now I want to find the distance of BC. I want to find this segment here. And so let's use a different color for that. So the distance between B and C. And again, I can call either one. I'll call this x2, y2, and this x1, y1. So the difference of my x coordinates, so 3 minus 2 squared plus the square of the difference of my y coordinates, so 1 minus 3 squared. And if I simplify this, I get the square root of 1, this is 1 squared, which is 1, plus -2 squared, which is 4, and then this equals the square root of 5. So this side is square root of 5. Make that color match. And then for our last side, we'll find the distance between A and C. Again, applying the distance formula, difference in our y coordinates. Okay, so I've got 1 minus 1 squared. Oh, sorry, difference of my x coordinates here. So we go back, and so we've got 3 minus -2, so 3 minus -2. Always be careful with those negative signs, plus the difference of my y coordinates, which is 1 minus 1 squared. And that becomes 3 minus a -2 is 3 plus 2 squared, which is 25. So I get 25 plus 0. I guess I don't need this big long radical here. 25 plus 0 squared, which is just square root of 25, which is 5. So this piece right here has a length of 5. So now we found the length of each side of the triangle. And now it says to verify that the triangle is a right triangle. Okay. Well, if it's a right triangle, then it will, the sides will fit the Pythagorean theorem. Okay. And so I'll take, we should be able to show by taking this side squared plus this side squared should equal the hypotenuse squared. Okay. And so we've got, let's change colors here. We've got 2 times radical 5 squared plus radical 5 squared. And we're asking ourselves, does that equal 5 squared? Okay, that's what we're trying to show here, to show if it is a right triangle. Okay, and so radical 5 squared times radical 5 squared is just, that's going to be 5. Okay. 2 times radical 5 squared is going to be, that's really just 2 times radical 5 times 2 times radical 5, which is just equal to 4 times 5, which is equal to 20. 20 plus 5, and 5 squared is also 25. So I think we have shown that that does indeed work. Okay, so it is a right triangle. So we can come up here and say, yes, it is a right triangle. And then it says find the area of the triangle. So the area, if you remember, of a triangle, so area is 1/2 the base times the height. And so since it's a right triangle, the legs will form the base and the height. So here's our base and here's our height, okay? Or vice versa. And so we've got 1/2 times 2 radical 5 times radical 5. And if we multiply this out, radical 5 times radical 5 is just 5, and 1/2 times 2 is just 1. So we get 1 times 5, which is just 5. So that is our area. And so we've plotted the points, we've determined the length of the sides by using the distance formula. We've proven it's a right triangle using the Pythagorean theorem, and then we were able to determine the area of the triangle. And I guess I should say this is 5 square units. We weren't given units, but you should be careful to note those things where you can. So there you go.